Hey everybody, back again. Day 2 of area. On day 1, we focused our attention on finding the area of a triangle and a parallelogram. Now it's on to the trapezoid, rhombus, and kite. So quick review of those formulas. Area of a trapezoid. That's going to be taking 1/2 its height, so finding that altitude, and then multiplying that with the sum of the bases, which I'm going to call base 1 and base 2. Okay, so half the height times the sum of the bases. Rhombus and a kite, got good news for you. They're the same formulas. All right, the area of a rhombus is 1/2 d1 d2, and it's the same for a kite. Okay, 1/2 d1 d2. And a reminder from last time's notes that d is equal to the diagonal length. Okay. All right. Because we are going to be doing some problems with rhombus and kite, odds are that they're not going to give you exactly every single piece you need and find the area. You're going to have to find the diagonals probably on your own, then find the area. So it's a good idea right now that we go over the properties that may help us out finding the diagonal lengths. So rhombus properties from when we were together doing our quadrilateral unit, all sides congruent. Okay. Now specifically about the diagonals. Diagonals are perpendicular. And another key fact, because it is a parallelogram, the diagonals, maybe you know, diagonals bisect each other. Okay, the diagonals bisect each other. All right, so hopefully that will help you out remembering when working with a rhombus. All right, kite properties. Diagonals are perpendicular as well. Okay, and just let me get a quick kite out here so you can see what's going on. Oh, that's a beaut. Two adjacent sides congruent. Diagonals are perpendicular. Okay, so what happens now is the diagonals don't bisect each other, but one of the diagonals bisects the other one. Okay, and that is the longer diagonal bisects the shorter. All right. So in this case, right there, 1, 2, 3, 1, 2, 3, those would be equal. All right, so something to get you started with how to find the diagonal lengths if we need it. All right, let's continue on. Find the area of this kite. All right, so I'm saying area of a kite. I know the formula is 1/2 d1 d2. You guys don't need to do anything here except for add the darn things, huh? So I end up with 1/2. One diagonal length looks like it's 16. And the other diagonal length looks like it's 20. So that's all I needed, the full diagonal lengths. And that's going to turn out to be, what do I have here? 160. Remember, we're doing area, so it's always square units. Perfect. All right, let's keep trucking. Whew. Next one. One diagonal of a rhombus is 6. The area is 48. Find the measure of the other. All right. So we're talking about area of a rhombus, which is still 1/2 d1 d2. They tell me one diagonal measures 6, so I'm going to go 1/2 times 6. The area is 48, so I'll plug that in for A, and we're looking for the second diagonal. And you could plug an X in there if you wanted to. It's up to you. All right, so as we move along, 48 equals 3 times that second diagonal. Let's divide both sides by 3. So that second diagonal looks like it's going to be 16 feet. Perfect. Okay, 16 feet. All right, not too bad, right? Okay, here's where we're going to start applying some of the properties. Find the area of this rhombus. Well, I know the area formula is 1/2 d1 d2, but I don't have any full diagonals here. So can I use any of these properties of a rhombus to help me out? Right, and the answer is you're darn right I can. All right, I know for one of the properties is diagonals bisect each other. So these two diagonals are congruent, which means if that's 40, the other piece is 40. So I can at least say one of the diagonal lengths is 80. Okay, how do I get the other diagonal length? Because they are not congruent in a rhombus, but they are perpendicular. All right, so going back, remember that was 40. Can you find this missing part right there? Not the full one, but missing part. I can do Pythag because it's a right triangle. So I can say x squared plus 40 squared equals 50 squared. Give you guys a second. Go ahead, solve for x. X is going to be equal to 30, but again, that's not the diagonal length. That's half the diagonal. I got to double it so I can go back and plug in 60. Okay, so the two diagonals were 80 and 60. So I used my rhombus properties in Pythagorean theorem. So the area of this rhombus here is going to be 2,400 square inches. Perfect. It's looking good, guys. All right, let's move our attention to the old trapezoid. Okay, trapezoid. Find the area, leave it in. Oh, it's been so long. We've missed you. Simplest radical form. You know you missed it. All right, let's first start out with the trapezoid formula. 1/2 the height, b1 plus b2. Look at the diagram. What am I given? I'm given two bases. So 1/2, we'll find the height in a second. 6 plus 11. Okay, remember height comes from a vertice perpendicular to the opposite side. So I'm going to draw my own height in here. Perpendicular to the opposite side. There is my height. Can I find that height? You're darn right I can. It is part of a 45, 45, 90 triangle. Can you guys get me another side of that 45, 45, 90? Well, I just split this into a rectangle and a triangle. So if that's 6, that's 6. The whole thing was 11, so that's got to be 5. All right, and let's go over. I know we did it in day 1, but let's do it again. 45, 45, 90, even though I know a chart's not required here, but XX and X radical 2. Where is this 5 across from? It's across from the 45. And where's the height across from? The other 45. So both of those are always the same. So the height of this one's going to be 5. So I got area is 1/2 of 5 times 17. The area of this trapezoid is going to be 42.5. And there's no units. So if there's no units, I don't expect you to put any on your answer. All right, 42.5. All right, now real quickly. All right, if you want to avoid memorizing this formula, all right, here's a way around it if you're interested. If not, then keep using the formula. Every trapezoid can be broken up into a rectangle and a triangle. So you got length times width here, and then you got 1/2 base times height here, and then add the two together. All right, so that's another way around it. Okay, that is another way around it. Okay? All right, moving right along. Next trapezoid. Oh, I see the old 60 there. I know what's coming. Know what's coming. So area equals 1/2 height, b1 plus b2. Once again, I'm given the basis. 7 plus 11. All right, now I got to get the height. Let me draw it in. I'll do it from P down. So there is the height I'm trying to find. All right, well, if that's 7, directly opposite side has to be 7, so that's going to be 4. Okay, here we go. 30, 60, 90 chart. Okay, I know across from the 30 is x, across from the 60 is x radical 3, and across from the 90 is 2x. I am given the side across from 30 is 4, and the height is across from 60. So I'm going to have to say that's going to be 4 radical 3. There's your height, 4 radical 3. Now the directions did say simplest radical form, so keep that in mind. So 1/2 4 radical 3 times 18. I can take half of 18, right? That's 9 times 4 radical 3. And now just multiply the 9 and the 4. 36 radical 3, no units, so no units in my answer. Okay? Whew, all righty. And then we come to Amelia's Pennant. We'll do this one together, and I'll let you do. Actually, we're going to have to do 35 on your together. So what I'm going to do is I'm going to let you try out number 5 on your own. I'll get you kick-started, and I'll let you go. So Amelia designed the pennant for her team. Great. Go team, go. Find the area of her team's pennant. Well, it's a trapezoid, so I know it's going to be 1/2 height B1 plus B2. All right, but now take a look. The only thing I'm given is one base. So the only thing you can fill in here is 10 plus something. All right, so you're going to have to find out, again, ready? I'm going to highlight it for you guys, and I want you to think about it. What is that other base? And now that I look at it, you are given the height. All right, I see something coming from a vertice perpendicular to the opposite side, so you are given the height, which is 4. So 1/2 of 4. Now the only thing you're going to have to work now is what's that other base? Okay, what is this blue parallel base right there that's parallel to 10? Okay, here's a hint. Draw the other height down, which you know is 4, and then work from there. Okay, so I'll let you guys go. Find that other height right now. Find the other base, please. Find the other base. Get after it. Go. Pause it. Okay, guys, I got a final answer of 25 square inches. All right, how did I get there? All right, because again, here is the other base I'm putting an X on right now. That's the other base we needed to find. So what I did first is, again, I drew the other height down. I knew that was 4. Then I did Pythagorean theorem on this right triangle here. Okay, I did Pythagorean theorem there, and as you can see my work right here, I did leg squared, which was 4, plus b squared, which is the other leg in green, equals the hypotenuse squared 8.5. I did all that out, and I got the square root of 56.25. But that's not the other base. That is just this part right here is the square root of 56.25. All right, see that right there? That is. So what I needed to do was I needed to subtract that from 10, which is my work right here, and I got 2.5. So if this piece is 2.5, the opposite side also has to be 2.5. So that's how I ended up with that. And I plugged 2.5 back in and got 25 square inches. Okay. Next up, if you need to pause the video, please do so. Make sure you have a calculator handy and make sure it's in degree mode. All right. Make sure that bad boy is in degree mode. Hopefully I'm not giving away what's going to happen here, but it's got to be in degree mode right now. Okay, next up, find the perimeter and area of the shaded parallelogram below. All right. So we can start a lot of different places here. Perimeter first. So I know one side's 12, and that must mean the opposite side is also 12. All right, what about this side here? I'm going to call X. Well, yeah, I can't do Pythag because I only have one side. It is a right triangle, though, and they give me this as 35 degrees. So what we're going to have to do here, kids, is go back a couple units and do a little sine, cosine, tangent. SOHCAHTOA, Pocahontas' brother. All right, so here we go. Quick review. I'm going from 35. The 4 is opposite. And the side I'm trying to find, X, is the hypotenuse of that right triangle. So what do we use with O and H? We use sine. So to set this up, I'm going to say the sine of 35 equals opposite 4 over hypotenuse x. Love the geometry. It always comes back. All right, just because we end a unit doesn't mean it's gone for good. It always comes back. So I'm going to put this over 1 and I'm going to cross multiply. Okay, 4 equals sine of 35 times x. You guys are going to divide both sides by sine of 35. And we're not going to round anything to the end. So I'm going to take my fraction template. And on top, I am going to put 4 on the denominator. I'm going to put sine of 35. Again, calc in degree mode. And get rid of that sucker. And that's what I'm going to end up getting, 6.973787182. And that's the side of the parallelogram. So that goes here, plus opposite sides are congruent here. So the perimeter is going to be equal to, just going to keep that right there. So I'm going to say plus that answer again, plus 12, plus 12. And I end up with 37, the directions say nearest hundredth, 37.95 yards. There it is. Okay, now we'll be back here in a second. What about the area now? Area of a parallelogram from day 1, base times height. All right, so the area, base, and here's the height right here, right? Vertice perpendicular to the opposite side, and it's drawn to a base of 12. I just got to find what the height is. Okay, so we have a couple options. Since we just found x, we could do Pythagorean theorem with the 4. Or we could say, all right, now to the 35, that's adjacent. And I could do opposite over adjacent, which is tangent. I could do, since I just found the hypotenuse, I could do adjacent hypotenuse, which is cosine. So again, I'm going to pause the video. You guys find that height by doing Pythag, tangent, cosine. All right, you decide, okay? So go ahead, pause the video. You guys find height. Okay, guys, I decided to use tangent over here in yellow to the right. I said tangent of 35 equals opposite 4 over adjacent, which I called h, which is the height. Cross multiplied, I ended up plugging in my calculator, 4 divided by tangent 35, and I got about this number right here, 5.7 and change. If you did Pythagorean theorem, it might be 5.7, but maybe not the numbers following, which is fine. You multiply that by 12, and we all should have ended up with an area of 68.55 square yards. Okay? So hopefully that's good. Down below here, all I did for you guys was just a reminder of all the special area formulas that we went over. Okay? Because the day 3 will be dealing with circles, which is a totally new beast. Okay? And hey, you're welcome. Look at this. 18, 19, 20, and 21. That's it. All right? Now go get the job done. Thanks, guys.